So here we're going to focus on solving radical equations. Again, this is something we've done a little bit already, so this shouldn't be new. It's just like solving any type of equation, but now we might have radicals or rational exponents to deal with. So what are our steps? First, the thing we want to try to do, if possible, is isolate the radical on one side of the equation. This is not always possible because we might have more than one radical term. We'll see that today. Once we do that, then we want to raise each side of the equation to the index of the root, so to that power. So for instance, if it's a square root, we would square both sides. If it's a cube root, we would cube both sides, and so on. If it's a rational exponent, then we want to raise both sides to the reciprocal of that rational exponent. And remember, the reciprocal means the same fraction, you just flip it. And that will eliminate the radical. Once we do that, then we just solve the resulting equation. We are also going to have to check our solution, not just because we want to make sure we don't make a mistake, but because this is another situation where we might end up with extraneous solutions. So remember, extraneous solutions are something we've talked about before. Those are solutions where we did all of the math correctly, but if we plugged that number back into the original equation, it actually just wouldn't work. So this is a situation where that can possibly occur. Okay, so here I'm going to do the first one, and then you're going to do the second one. So let's go ahead and talk about our steps. So remember, our first step was to isolate the radical. So the radical here is this part, and so to isolate that, I want to divide both sides by 2, because the 2 is on that side, but it is not inside of the radical. So I end up with the square root of x plus 1 equals 3. Now the second step was raise both sides to the index of the radical. In this case, it's a square root, so that has an index of 2, so I'm going to square both sides. In doing that, the radical and the exponent on the left-hand side go away, or they cancel each other out. On the right-hand side, I get 9. Now, last step was just solve the equation, right? So in this case, I would subtract 1 from both sides, so I get x equals 8. Now I need to check. If I was to plug 8 back into the original equation, and then I do this arithmetic, do I actually get 6? So 8 plus 1 is 9. The square root of 9 is 3. 3 times 2 is 6. So that works. If you don't want to do the mental math, just type it into your calculator. Another big thing, just to give you a hint, actually, what really we're looking for is underneath the root, does it create a negative number? Not that this can't be negative, but if underneath the root I get a negative number. All right, so I want you to try B. Pause the video, solve that equation, unpause when you're ready to check. So here, going through my steps, isolate the radical first, so this is the radical part, so I added 1 to both sides, so that's how I got the blue here, cube root of 2x minus 9 equals 3. Now I noticed that it was a cube root, so the index is 3, therefore I want to raise both sides to the third power so that the cube root and the cube cancel each other out. Just a side note, remember that that happens because if I write this as a rational exponent, the cube root of 2x minus 9 is the same as 2x minus 9 to the 1/3. And so if I raise that to the third power, then I'm multiplying 3 by 1/3, which is the same as 1, and that's why it cancels out. All right, that was just a little digression there. Hopefully we understand that. So 3 to the third is 27. The root is gone over here now because I raised it to the third power. Now I solve the equation, add 9, divide by 2, I get x equals 18. Plug that into the original, make sure it makes the equation true. It does, so I'm good. Okay, next one. Now we're going to go through this one again because this is going to be a little bit more work. So our first step is isolate the radical. Well, the radical is already isolated. So now we can just go ahead to the second step, which is to raise both sides to the index of the radical. And since this is a square root, I can square both sides. Here, this will go away. And now on the left-hand side, remember that x plus 1 quantity squared is the same as x plus 1 times x plus 1. So I need to actually distribute, and I end up with x squared plus 2x plus 1 equals 7x plus 15. Now I'm going to solve, so I'm going to subtract 7x, x squared minus 5x, and I'm also going to subtract 15, so minus 14 equals 0. This is a quadratic equation. I have many ways in which I can solve a quadratic equation. In this case, it factors, so I'm going to think about what multiplies to negative 14 but adds to negative 5. So that's going to be x minus 7 and x plus 2. Set each factor equal to 0. And I end up with x equals 7 and x equals negative 2. Now I'm going to check both of those answers in the original equation. So here, if I plug in 7, 7 plus 1 is 8. And here, if I plug in 7, 7 times 7 is 49. 49 plus 15 is 64. The square root of 64 is 8. So I get 8 equals 8. That's true. So that tells me this is a good answer. If I plug in negative 2, negative 2 plus 1 is negative 1. 7 times negative 2 is negative 14. Negative 14 plus 15 is positive 1. The square root of 1 is 1. So that means that negative 1 equals positive 1. That is not true. So this is extraneous. And again, it's not that we did something wrong. It's that if I plug it back into the original, it didn't work. So we do have a solution of x equals 7, and then this part is not an actual solution. All right, let's do this one together as well, just because, again, it's slightly different. So here, the radical term is the part with the rational exponent. And remember, that's because this is the same thing as the fourth root of 2x to the third power. Remember, that's what that 3/4 exponent means. So that's our radical part. So I want to isolate that. So I'm going to subtract the 2. So I have 2x to the 3/4 equals 8. Now from here, remember in the steps at the beginning, I said if it's a rational exponent, raise it to the reciprocal. So the reciprocal of 3/4 is 4/3. So I'm going to raise both sides to the 4/3. Again, the reason why I'm doing that is, remember, from our properties of exponents, we would multiply these together. And whenever you multiply reciprocals, 3/4 times 4/3, in this case, that always equals 1. That's why we're doing this. So I know this is going to cancel, and then I'm going to go to my calculator if I want, and I'm going to type in 8 to the 4/3, and I see that that's 16. So I'm going to get 2x equals 16. And again, just a side note, if we weren't comfortable with that or were confused on that, remember that this is the same as the cube root of 8 to the 4th. And the cube root of 8 is 2, 2 to the 4th is 16. So that's how that works. Now we can go ahead and divide both sides by 2, and we end up with x equals 8. It's a pure coincidence that that is the same as what we had right here. That is not always going to work out that way. Now we do want to check that. If I was to plug this in, 2 times 8 is 16, and I know that 16 to the 3/4 is going to be 8. 8 plus 2 is 10. So that worked. Okay, so now I want you to try a few. So I want you to try solving both of these. Pause the video, do both of them, unpause when you're ready to check, or if you get stuck. All right, so I actually want to talk about number 6 first, because this one was hopefully pretty straightforward. There's not a lot of work here, but we also hadn't seen an example exactly like this. So in this case, since we had a radical on both sides of the equation, but that's all we had, they both had the same index, so we can go right ahead and raise both sides to the second power since they're both square roots, and that gets rid of the roots. And then we're just left with 2x plus 5 equals x plus 7. So now I subtracted x over here and subtracted 5 over here, so I get x equals 2. I did check my answer, and that worked. It made the equation true. Number 5, this was a little bit more work, but we did a problem like this together. So here again, the radical was isolated to start with, so I can go ahead and jump to step number 2 and raise both sides to the index of the radical, which in this case is 2 because this is a square root. Just like before, x plus 3 quantity squared is the same as x plus 3 times x plus 3, so I actually need to distribute all of this, and I end up with x squared plus 6x plus 9 equals the 10x plus 9. Now, because I'm solving an equation, I want to get everything over to one side so I can get it equal to 0. This was nice because the 9's cancel, so I'm left with just x squared minus 4x. So now I can factor this by just taking out my greatest common factor, which is x, and then I can set each factor equal to 0, so x equals 0 is one of my solutions then, and then x minus 4 equals 0 tells me that x equals 4. Now again, I do need to check both of these answers and plug them back into the original equation, and when I do that, it makes both sides of the equation true, so those are both good answers. Nice work. I knew you could do it. All right, one more. Same thing. I want you to try this on your own. Pause the video, unpause when you're ready to check. All right, so for this problem, we should end up with x equals 6. We also got x equals negative 5, but that is an extraneous solution. Let's look at the work, though. So first, I have x plus 30 to the 1/2 equals x. So remember, this is a rational exponent, so I raise it to the reciprocal of that. Since this is 1 over 2, I can raise it to the 2 over 1, which is the same as just 2, or squared. So I raise both sides to the second power, and then that eliminates the rational exponent, and I'm left with x plus 30 equals x squared. Now, since this is a quadratic equation, bring everything over to one side, get it equal to 0. This, again, is going to factor nicely what multiplies to negative 30 and adds to negative 1. That's going to be negative 6 and positive 5. Set each factor equal to 0. Solve, and I got 6 and negative 5. Now I want to check both of those answers. And I see that if I plug 6 into both sides of the equation, it makes it true. But if I plug negative 5 into both sides of the equation, this side becomes positive 5 and this side is negative 5. One thing to point out with this, so again, in terms of answering the question, if the question says solve or find all solutions, your answer is x equals 6. I would get in the habit, though, of, one, you definitely need to find this answer, but two, identifying that it's extraneous just so you get in the habit of understanding, okay, I did this work, I found this answer, I don't want to erase it, it wasn't wrong, but it's not one of my solutions. Then the other thing I was just pointing out here was just remember that x plus 30 to the 1/2 is the same as the square root of x plus 30. So that's another way to think about the problem, and also then understanding why squaring both sides gets rid of the radical or the rational exponent. Okay, so just make sure you understand your steps for solving radical equations. Isolate the radical on one side if possible. Raise each side of the equation to the index of the root or the reciprocal of the rational exponent, depending on which form the radical is in. That will hopefully eliminate the radical, and then solve the resulting equation, but don't forget to check your solution.